Hello, students, looking at homework set 13-1. And we've got some questions here. Now, again, it looks like a lot, but again, when you start looking at it, the reason there's many of them is that you need to see the context in slightly different ways, but also a lot of these are going to be very quick. Let's take a look at a few of them. 1, 3, 5, go from here. Notice question 1 is find the picture of the ruler and find how long is AB. So when you look at this, again, this is not intended to take a long period of time. It's meant for you to say from A to B. What is that distance? It's measured in inches. So you write 1 inch. That's it. Now notice it is marked. So there's 1 inch, then you have half, you have quarters, and you have eighths. So if you're measuring something like D to E and you know you have eighths, you can just count them off. 1, 2, 3, 4, 5, 6. That's 6/8, which is 3/4 of an inch. Again, meant to be like, hey, let's get into the rhythm of this and figure out how we can do it. Okay, meant to be pretty quick, but again, a good review if you haven't done this in a while. So I did 1, I think I assigned 3, convert to units. Okay, inches to feet, so we've done that. Again, take what you know, start with that. So if we were doing part D and I had 372 inches, I'd write it over 1. My goal is to get to yards. I don't have yards right here. So I could go from inches to feet. And I know that 12 inches is 1 foot. So I'd write that in. Then I could go from feet to yards. And so I know that 1 foot is, 1 yard is 3 feet. Let me make sure I get that right. There we go. So feet go away, inches go away. I'm in yards now, and I can just multiply 372 times 1/12 times 1/3. Some of you may know that 1 yard is 36 inches. That's up to you. I'm not saying you have to memorize it. Clearly, you could just write it out here. It's not required, but that would be kind of the approach for those. I meant to be fairly quick. Estimate the length. So just look at this length that's on your page and then measure it. Now, this will be challenging if you're using the ebook. So if you use the ebook and you zoom in, it's going to look bigger. So try to do this where you're zoomed at 100%. And that'll give you a pretty good idea if you're on the right track. Estimate it, and then measure it. Now make sure you express the measurement in each of the following units. So when you put your ruler up there, and you're measuring it, you can see it in millimeters, which is the tiniest tick marks on the other one on the metric side, and centimeters is like the bigger tick marks. Okay, let's see. I think what we have next, 8 through 11. Okay, so complete the following table. So this is kind of where we're just moving decimal places around. This is meant to be very, very quick as you get used to it. We're only doing meters, centimeters, and millimeters. So King Henry's dear mom drinks chocolate milk. I don't even need this part. So if they give me meters, I can move it 2 spaces to the right and I get centimeters, and I can move it 1 more space to get millimeters. And that's it. That's it. It's meant to be very quick. I want you to get familiar with it, and the way we do that is with practice. All right, let's see here. 8 if eggs are sold in the U.S. using metric prefixes, the base unit for a carton of 10 eggs. Go ahead and tell how many eggs are in the following cartons. Perfect. So now think of a carton holding 10 eggs. What would be a hectocarton? What would be a kilocarton? How many eggs would be in there? Okay. A little practice with the prefixes in the metric system. Whew. For each of the following, place a decimal point to make it reasonable. A basketball player was this many centimeters tall. Okay. And now this is where, when you're using the metric system, some of you are going to find yourself, you're like, I have no idea. But to get familiar with it, think about if we were to transition this and say, okay, let's do something in the metric system so that we have a reference. 1 meter is approximately 3 feet. It's not exactly, I know that, but if I'm doing something very quickly, it works nicely. 1 meter is 3,000 feet, right? 1 meter is not 3,000 feet. 1 meter is 3 feet. Notice they're measuring in centimeters, right? Well, 100 centimeters is 3 feet. That's really what that's saying. So as I look at this, How tall would be a good basketball player? A basketball player probably is going to be around 6 feet tall, which would be about 200 centimeters. So I just put the decimal point where it makes sense in this problem. It would not make sense to put the decimal point at 19.50. 19 centimeters, so 19 centimeters, 20 centimeters, about 6 feet. Move the decimal one place, and that's about 0.6 feet. So it's like a half of a foot. That doesn't, right? See what I'm saying? That doesn't make any sense for a basketball player. A new piece of chalk. How long would a new piece of chalk be? And so get an idea here, right? So you could think of 1 centimeter is defined to be 2.54 inches, but that comes a little bit hard. I like to think of 2 centimeters is about 5 inches. Those are whole numbers. Those are easier to work with. And I know it's an approximation, but it's pretty quick, right? Well, how long is a piece of chalk, right? Is it 6 inches long? Is it 5 inches long? What would it be? Is it 4 inches long? Is it 3 inches long? And honestly, it's probably less than 5 inches. So that gives you a pretty good idea. And again, just trying to get a feel for what is this different system. Speed limit in town is 400 kilometers per hour. Okay, so to have an idea, okay, take a moment and do one conversion so that you have a rule of thumb. So if you were doing, let's see here, miles per hour into kilometers per hour, notice that the miles and the kilometers are different, but the hours are the same. So if you needed to, like, do one conversion just so you have a feel for what is the metric system doing with these type of numbers. So let's take a look. Let's just say, what would be a good speed to have? Let's go 40 miles an hour. Okay, so I'm going to get rid of miles. We're going to do this one together. 40 miles. So I'm going to get it. So 1 mile is 5,280 feet. And I know 1 foot is 12 inches. Here comes the fun. Metric system time. 1 inch is 2.54 centimeters. And so now inches are gone, feet are gone, miles are gone, and I'm in a very crazy unit of centimeters per hour, which is going to be massive. So I need to get rid of that and move back to kilometers. So King Henry's dear mom drinks chocolate milk. From centimeters, I'd go 1, 2, 3, 4, 5 decimal places. Okay, so times 10, 10, 10, 10, 10, that's 5 zeros. And that's how many centimeters make 1 kilometer. Okay, now what do? I just multiply it. So grab your calculator, do this one, hit pause if you need to. I'm just going to open up my calculator and do this one with you. There we go. So I have 40 times 5280 times 12 times 2.54. Okay, right now I'm at like 6.4 million, but now I divide by 100,000. Okay. So 40 miles per hour turns out to be about 64 kilometers per hour. All right. All right, so there you go. So that gives me a good rule of thumb. 40 miles an hour, 64. Got it. Okay. All right. So if they say the speed limit in town is 400 kilometers an hour, you'd be like, that doesn't make any sense. So you're putting a decimal point. So your options are 400, 40, or 4. And just remember, our rule of thumb was 64 kilometers per hour. That was about 40 miles per hour. So if you're driving through a town, would you be going over 40 or under 40? And if it were you, I'd probably say under 40. So if I'm going less than 40, then it's got to be less than 64 kilometers per hour. And this one seems reasonable. Okay. All right. Oh, you know what? I did mention something in class and then I I didn't end up having time for it, so I apologize for that. But if you are watching this video as an added bonus for you, I'll give you a quick way, quick way of moving between miles and kilometers. And let's see here. So what we just showed is that if we were doing this 1 mile, if I multiply, so 1 mile is 5,280 feet, right? And then 1 foot is 12 inches, right? And then 1 inch is 2.54 centimeters. And if I want to get this back into kilometers, again, which is a good one, we do the 100,000. That's how many centimeters are in 1 kilometer. Now, the reason I bring this up is if you just had your calculator there, just take that number that you found and divide by 40, because we started off with 40 miles per hour. Get rid of the hours, get rid of the 40, divide by 40, and what you'll have is 1.609 kilometers, which is approximately 1.61. Okay. Why is this cool? Well, it turns out that the Fibonacci sequence that looks like this, oops, 5, 8. Remember, you add the 2 digits to get the next one. So this is a really cool sequence. But the limit of the Fibonacci sequence, when you take the ratio of the terms, the limit of this, as you get out to infinity, just go over and over and over, you get close to this thing called the golden ratio. And the golden ratio is about 1.6, 1.61. So what you can do is, if you need to get back and forth quickly, is you can find numbers that are very close, and then that'll get you a really good estimate. So for example, and the miles will always be a little smaller, just understand that, okay? So what you do is you pick 2 numbers right next to each other. So these, what does these tell me? This tells me that 3 miles is about the same as 5 kilometers. So if I was doing a 5K run and I don't have no idea what kilometers are, I know it's about 3 miles. Okay, a fun run, it's about a 3-mile run. Got it. Okay. What do we say? 40 miles an hour? Okay. I don't really have numbers that are really close together, but again, I can always add pieces to make them nicer. These 2 numbers, I'm going to tell you why they look pretty good. So this is about 42. If I double it and I double this one, gives me 68. So 42 miles per hour is about 68 miles per hour. And there's a very quick rule of thumb. Okay. Let's see here. What else could, yeah, do any 2. As long as you take 2 of them right next to each other, you'll be good to go. And you can also add them together if you wanted to. So let's just say that I had a, I don't know, what do I do? I'll do an 18 kilometer. Like, what's a good estimate for 18 kilometers? Well, what you could do is you could say, okay, let me take this right here. So 18 kilometers is like 13 kilometers, which is 8 miles, right? And let me come over here and I need, let me do a 5 and a 3. So I'll add 5 kilometers, which is about 3 miles. And now I know that 18 kilometers is about 11 miles. Okay, there we go. So I've got a pretty good idea. Okay, that's a quick rule of thumb using the Fibonacci sequence to find things that are very, very quick. The higher you go, the closer your estimate. So take a look over here. 2 miles to 3 kilometers. I mean, it's close. What that is really saying is 1 mile is 1.5 kilometers. We know that it's a little bit more like 1.6. But again, for a very quick rule of thumb, this is a very quick way to get an answer. 8 divided by 5 is 1.6. Hey, that's really pretty close. And if you keep going, you get really so close to the number we had. If we do 34 divided by 21, I get 1.619. You're like, okay, thank you. I might as well be sitting right at that number. And if you keep going, 55 divided by 34 is 1.617. So again, the golden ratio is a little bit bigger than this number. I think it's 1.618. And our number is 1.609, but it's so close that why not use this if you need a very quick way to get there? Okay. All right, so there we go. That's how you can do it. So if you saw a sign that said 100, I don't know what everyone would say, 100 kilometers per hour is the speed limit, and you don't have kilometers per hour in your car, find a quick unit that's close, like 21 is close because 20s, a whole bunch of 520s gets me there. So you could just say, okay, 21 over 13, and I multiply by 5, and this gives me about 105, and 50 and 15 gives me 65. So 65 miles per hour gets me to 105 kilometers per hour. There we go. So pretty cool. Nice little technique. Hopefully you find this useful as you're kind of getting some reasonableness to your answers as well. Let's see here, 8, I think I went through 11. Find the following in decreasing order. So these are just different metric numbers. Put them in order as you go. 9 to 11, then I got 13, 15. The following is a circle, whose radius is 2. The diameters of 2 semicircles are larger, also 2. Complete the length of the curve that separates the shaded and the white region. Yeah, so this is kind of that trick at the beginning of the section. This piece right here is a half circle. The other piece is a half circle. So put those together and you really just have a whole circle with a diameter of 2 centimeters. So circumference equals pi times diameter, and you can get there. 15, hey, King Henry's dear mom drinks chocolate milk. Give it a little, move those decimals, and you can get there. 15 through 18, okay. Explain in your own words why the triangle inequality must be true. Now, this can go back to chapter 12. We were doing congruence, and they said, can you construct a triangle like this? Think about what it means. How could you tell this to a young, especially a young child in your class? Can the following be sides of the triangle? This is the triangle inequality in action. Just check and see. It's not asking you, is it a right triangle? We'll get to that very soon, where you can look at those 3 measures and tell me, is it not just what kind of a triangle is it? Can you make a triangle? Is it scalene, acute, obtuse, and or right? Let's see what else. 2 sides of a triangle have these lengths, and the measures of the third side must be a whole number. What's the longest the third side could be? What's the shortest it could be? So remember, 2 sides, triangle inequality, 2 sides have to add up and be bigger than the third side. So think about that, and remember it has to be a whole number. All right. There's 18, 20 to 22. So let's see here. I think next page. Question 20. Here are circumferences. Find the radius. There we go. If the circle has the given parts, determine the circumference. Here's the radius and here's the diameter. Again, find the circumference. Okay. And let's see here. What else? 20 to 22 and then 24. How does the radius of a circle change as the circumference is doubled? Think of this as an equation. Write out the equation for circumference. If you double the circumference side, double the left-hand side, what do you have to do to the right-hand side? And what does that imply about how the radius changes? Okay. I think 24 was give the greatest possible error. So again, if we're using a half of a foot, is a tough one here. I can't tell if they're measuring to the half foot or they have a decimal number here. So if it was to the half of a foot, I would prefer they'd write it this way. They wrote it as 3.5. So I have to assume that 3.50 would be the next place that they would get. So then go up and down to this decimal place, you'd have 0.05. Okay. And let's see here. What else? So 24 and then 26. Suppose the radius of a circle containing a 60-degree arc. Find the radius, and the length is 12. Okay. So again, this seems like it's going to be really, really challenging. But if you remember what I talked about, the arc length is the circumference, 2 pi r, times some fraction. The fraction of a whole circle in terms of an angle. So if somebody puts in 360 degrees, that's the whole circle. So your arc length would just be 2 pi r. They tell you it's 60 degree. So put in 60. You're trying to find the radius, and they give you the arc length. So over here on this side, put in 12 pi. On the other side, you have 2 times pi times radius times 1/6. This is the equation. There's only one variable left. Use what you remember from chapter 8, and you can solve that equation to find the missing piece. That's it for homework. If you have questions, let me know. I can meet you on Zoom. I can meet you on campus. I can meet you in person. I can make another video. Just let me know how I can support you, and have a good rest of your day. All right, off you go.